Wow, this is advanced robotics, guys. This is peak physical AI. On this channel, we're on a journey of going all the way from zero to physical AI with a lot of hands-on experience, a lot of trial and error, well, mostly a lot of error, but figuring it out together. Because really, when you have the right attitude, how hard can all of it really be? And today, we're really going to put that to the test. I'm giving myself 1 day to learn ROS. You know, notoriously one of the most complex and hard to get parts of robotics. Why am I doing this? Well, frankly, because I'm severely behind schedule. See, my first plan was to start learning ROS with hardware, because who doesn't like looking at a really fancy robot doing a lot of cool stuff? That's what I've been doing on this channel so far. And I even managed to land this amazing deal where the University of Amsterdam is going to land me one of their rovers. Well, actually, how cool would it be to go from a 3D printed DIY robot arm to this, with LiDAR and sensors and being able to automatically follow paths and do a lot of stuff with ROS. Pretty cool, right? Well, it's not happening, and I am very bitter about it. I was so excited to get this. I got it home from the university on buses and trains. We went on quite the journey together until eventually it made it to my studio, where I took it apart and we looked inside together. We checked out the NVIDIA board that powers the whole thing, because robotics, physical AI, and NVIDIA are pretty much synonymous these days, and I was so excited to get started with it on my own. Instead, what happened is that I somehow managed the impossible and burned the robot. Sadly, I wasn't filming at the time, but here's a dramatic reenactment. Now, I'm still not 100% sure what happened. This rover has a lot of parts in it besides the NVIDIA board, which should be more or less protected from short-circuiting, but there's also some electronics board in there. However, I am too terrified to plug it in again and know for sure. What we should do is take apart all the parts and test them separately. I do not have the strength to go to another failed hardware project, so instead we're going to focus on ROS, the software way today. And really, when you think about it, this just puts into perspective how incredibly ridiculous learning robotics is. Think about when you started to learn coding. If you make a few mistakes, and you probably made a lot of them, you just get error messages, you just get pop-ups, and you just have to fix it, and it's fine. Now imagine that every single time your code failed to compile, there's a pretty high risk that your code just starts smoking or exploding instead. How would anyone learn anything? And that's what I want to ask to the entire field of robotics, because I'm feeling pretty discouraged right now. However, it doesn't matter. We must persevere and go on. So what I'm going to do instead is try to set up ROS on my computer, try to get some of the basic hello world equivalents, which is of course the turtlesim, figuring out how that works, getting a basic understanding of the concepts, and maybe trying it out on one of my Raspberry Pis that I have at home, just because if I burn that, it's a lot easier and cheaper to replace than a 1K rover. Yeah, that one still hurts. So we're going to walk through it together, we're going to figure out the ROS concepts, and at the end, hopefully we have something running without any smoke. That is the new threshold that we judge all our projects by. Let's go. So the first thing to know about ROS is that it notoriously mostly only works on Linux. So if you have a Windows or a Mac computer, well, kind of out of luck. Although there are some creative ways to get around it, which we'll take a look at, but mostly the best thing for you to do is to get some kind of Linux system running. Now, in my case, I have my PC set up here, and I've dual booted my Windows PC to also run Linux in parallel. I just installed Mint on it, and we're gonna try to work in this virtual environment instead. Now, how most people would learn ROS is, well, probably within a classroom if you're studying some kind of robotics degree, or by going through course materials. There's a lot of really good videos on YouTube as well, but from what I've seen, there's like hours and hours worth of playlists that just get you through setting it up. I really don't want to go through all of that, so we're gonna compress it as much as possible, and I'm actually gonna try to use Claude for this video to see if that speeds up the process at all. So, how do I start with ROS? First thing first, figuring out which ROS to install, check out which Ubuntu system you're running. In my case, it's even one layer deeper. I have Linux Mint 22.2 Cinnamon, which is equivalent to the Ubuntu 24, which then means I need to use ROS2 Jazzy. Because apparently Linux people really love making it very hard for other people to understand what is it that they're talking about. It's just code names on top of code names. And I feel like we're going to run into that a lot. But regardless, I know I need ROS Jazzy, so let's try to install that. I'm going to do sudo. Apparently my Ethernet cable's not in. Noble, Jammy, Bookworm, are you serious? Why? Why are there so many instructions just to download it? Okay, a lot of stuff is happening. Still going, still going. Nope, still going. 20 minutes later. Okay, so I guess be prepared to spend your first hour of learning ROS installing ROS. There's a little turtle. What does this mean? Open a new terminal. Okay. I just want to control my little turtlesim. Okay, so we installed ROS, but then it says command not found because I didn't add it to the path. So we're gonna add ROS to the path, and now when I say ROS2, it actually works. Then can I do ROS2 node list? I'm starting to get it. Wait. Okay, so we have the turtlesim that I started with this terminal. And then when I run this in the other terminal, I see that the node for the turtlesim is on. So it's all kind of communicating. Teleop key. Use the arrows. Oh my god, this is so cute. Are you serious? Oh my god. I love this little turtle. I love it. We're teleoperating it by running it from here. And then what's happening? I don't know what we're doing, but this is so much fun. It's like a video game. A very lame video game. But I love it. I try to draw a heart for you guys, but... Open a new terminal and install RQT. We are on our third terminal, so you know things are getting serious. I don't know what I'm doing, but it's so much fun. Oh, a GUI, of course. We do need a graphical interface. Okay, so this is just a way to call the actions without using the various command lines. How do I... Yeah, oh! It's now thicker. And what if I do... this? It's now red! There she comes. Wow, this is advanced robotics, guys. This is peak physical AI. Okay, so basically we've used no coding. We've just used these commands to modify the nodes and the topics and the parameters that we have for these turtles. We can spawn them and then each of them get a node. Is that correct? So if I do ROS2 list nodes. There, now we have 4 different turtles and they each have their own topic. So the node is turtlesim and we have different topics from the different turtles that we've spawned and they can all do different things. Am I understanding that correctly? So each turtle is a different topic and these topics can send messages to different nodes and different services can request services from different nodes. Am I getting that correctly? What? Let's pretend that made sense and move on. And now we're gonna start giving commands and remembering those commands to run later, which also makes a lot of sense. So this is the data that we've collected. Is there really the need to have that many freaking terminals? Oh, it's doing it. Look, no hands. Okay, so I've recorded my actions in an mcap file and I can now play it from that recording. So you can teleoperate live and then you can make it redo commands that you've recorded as well. This is really useful, like what we did with the robot hands where you can teleoperate them live. This is the system that would allow us to do that for any kind of robot. So we're getting closer to what we wanted to automate. Okay, there we go, heart. No. Okay, so that did it at the wrong angle. If you look at it backwards, it kind of is a little heart. Okay, so with some extra documentation, reading and debugging, we're heading into hours 2, 3, I've lost track of time. We're gonna try to make our own package. So it seems like package is pretty much project, and we want them in a workspace. We sourced our ROS. I have a package. Okay, great. Not successfully, we have not. This is so confusing. Why did you make it so confusing? When in doubt, open a new terminal. I feel like that's the motto of ROS installations. Hi, from Julia Package! We have a package. 3 hours. 3 hours and we have a package that says hello. Okay. Like they keep saying beginner and they keep saying like, oh, 20 minutes. An hour later. It's okay. It's okay. It's okay. It's okay. How is this still beginner? Just make your own library. Excuse me? Write your own server. No, I don't want to do any of that. How about we go back to the last time we had fun? And that was the turtle sim. So I think we just make our own fun turtle sim. Motherload. Okay. So we can replace these images with new images. And then we want to spawn. And this one can still move, right? This is so much fun. Is it useful? Absolutely not. But it's fun. And now I wonder if we can control this. We can create the mcap files with the particular movements and then apply them to the turtles. So we should be able to set up a scenario in which all of these orchestrate beautifully, right? It's same info. All right, we are now severely pushing towards our 8, maybe even 9. So we gotta wrap this up and make it work now. So what we've done is we've set up the Raspberry Pi over here. I got it running with my external screen and keyboard and mouse. And we got to testing how stuff works. We installed Ubuntu. We got the ROS running exactly like we did on the Mint computer, only this time on this tiny little computer instead. Then I actually used SSH to control it from my laptop, so I have a little bit more control, and because I wanted to use Claude Code again, because of the amount of dependency issues that I've had to run through. It's basically been about 1 or 2 hours of just trying and forcing installing of packages over and over and over. I had to downgrade packages, I had to hold packages, I had to reinstall packages and add new different versions of different packages, and in the end, it still did not work. So what I ended up doing is using Pixi, like I hinted at the beginning of this video. It basically bypasses conda and pip and uv and all of those together and creates this binary that just runs on whatever platform or environment you need. So that's how you could run ROS on a Mac as well. And in this case, even though we had Ubuntu, it was still so incredibly annoying to put together, so we're using Pixi anyway. And we can actually use Pixi both on this Raspberry and on the Mint computer, and we can get them to communicate, which is what we're going to do. Because another blocker was the fact that on this Raspberry Pi, we're only using the server version. This is all we can see. So obviously we can't really run the turtlesim visualizer here because all of my beautiful faces knocking against the walls would simply not render in the command line. So instead, we're going to set this up as the node that controls all the microcontroller electronic key bits, namely this setup over here. And that's like the whole point of ROS anyway. We're able to run different nodes in different environments, each of them doing the best of their abilities. In this case, this node will be our little output that can either turn on the light or move the servo motor. And just to make sure, I first tested these with some very basic Python skills. I just ran some code on the Raspberry Pi to flash these little light bulbs and to move the servo left or right. This is very, very basic stuff, but the complex part is that the ROS node is going to be controlling this rather than this very simple line of Python. So we have this set up here to be the output. We finally got the Pixi to run, and it now says that it's waiting for a command underscore vel. That is the node that this communication is going to happen on, where the actions are going to be sent. And I'm going to go back to my Windows PC that has Mint on it, and I'm going to run ROS there and run the turtlesim, teleoperate the turtlesim, and that should control this. There you go. You can monitor the situation for us. And then let's go. All right, so this is where our original ROS setup happened. We're transferring this into Pixi as well, because that should be a little bit easier. We no longer need the hexagon turtles. Instead, we're just trying to run the very basic simulation and get it to work on the same communication layer as we have on our Raspberry Pi. So we're using the ROS domain ID 42. And hopefully this should do something. I will be honestly quite surprised at this point if it works, because it's been such a day. Guess what? A new terminal. Hopefully the last one for a while. Of course you do not know what Pixi is. Okay, this is ridiculous. Well, I would love to run Pixi install. Well, that's more bad. I'm terrified that this works. Wait. I'm hearing the servo. Wait. Oh my god! Oh my god! The light is on! Holy shit! This is so insane. So my oh my god, my computer over here, it's controlling from the ROS node on my computer all the way to the Raspberry Pi thing over there. Holy shit. Oh my god. This is physical AI. Oh my god, I've actually done it. I'm not gonna lie, I didn't believe that this would actually work. Okay, well, I think that's a great natural stopping point for this video. It is now almost 10 p.m. Did I learn ROS in 8 hours? Hell yeah, I feel like I did. Oh, this is exhilarating. It was one thing to get like the Raspberry Pi and the microcontroller stuff to work, but to get to control it from like across the room over this network with like custom nodes, this unlocks so much more, and I'm so excited for what comes next. We're going to run simulations, we're going to do some amazing visualizations and really, really pretty things, and so much more complex systems than this. A lot of stuff coming. We're just getting started. A lot more mistakes to come for sure, but today we had a success, and I'm so happy with this. I'm going to try to publish all the code that I worked through. I'll put the details in the description. Thank you so much for watching and for following along. We're in this together. I'm so proud of us, and I'll see you in the next video. Bye!